In this video, we'll work through two more examples of a one-sample t-test using SPSS. Past research reported mean critical thinking ability, as measured by the California Critical Thinking Skills Test, for adults entering the job market with a master's degree in the health sciences to be 21. We want to know whether mean critical thinking ability of UB Health Sciences graduates is any different. We conduct our study on a random sample of students graduating from UB with a master's degree in the health sciences, and we use the CCTST to measure critical thinking. We'll set the significance level at 0.05. The first assumption is met. The population we want to generalize to is all students graduating from UB with a master's degree in one of the health sciences, and we are drawing a random sample from this population. One individual's critical thinking score shouldn't influence another's, so we'll say that the independent observations assumption is also met. The last assumption is that the population distribution is normal. We have a large sample, so the central limit theorem tells us that the sampling distribution will be approximately normal. We are not looking for a difference in a particular direction, so this is a two-tailed test. The first output for a one-sample t-test is a table of descriptive statistics, and the second reports the t-test results. The null hypothesis is that the mean critical thinking score is 21, so we enter this as the test value. The p-value is 0.003, which is less than our significance level, so we reject the null hypothesis. The interval estimate is for the difference between the sample mean and the hypothesized mean, so we add the test value to these bounds to get an estimate of the mean critical thinking score. The t-test results indicate significantly higher mean critical thinking ability compared to previously reported results for those with MS degrees in the health sciences. We could also say that the mean on the CCTST is significantly higher than 21. We are 95% confident that the mean is between 1 and 3 points higher than previously reported for MS graduates in the health sciences, or that the mean is between 22 and 24. 30 years ago, a study of first-year dental students reported mean emotional stability of 28. A current researcher believes that emotional stability among first-year dental students is lower than it was 30 years ago. He administers the ES scale to a random sample of first-year dental students and uses a significance level of 0.05. The first assumption is met, and we'll assume that scores are independent of one another. The sample size is large, so we know that the sampling distribution of the mean will be approximately normal. The null hypothesis is that mean emotional stability is equal to 28. The research hypothesis is that the mean is lower than 28. The sample mean is lower than 28, but we need to look at the t-test results to know if this result is statistically significant. The reported p-value is 0.248, but this is a two-tailed value. We divide it in half to get the actual p-value, which is 0.124. This p-value exceeds the significance level, so the null hypothesis is not rejected. We would not interpret the confidence interval for two reasons. First, we did not reject the null hypothesis. Second, if we had rejected it, the confidence interval would have only one bound, because the hypothesis was one-tailed. But let's take a look at it. When we fail to reject the null hypothesis, the confidence interval for a mean difference will always include 0, with a negative lower bound and a positive upper bound. And if we change this into an estimate of the population mean, the interval will always include the hypothesized mean value. These results do not indicate significantly lower mean emotional stability for first-year dental students compared to previously reported results. We can also say that first-year dental students' mean emotional stability is not significantly lower than 28. The next series of videos focuses on the independent t-test.